So real quick, I'm going to be drawing the num coin using dynamic programming with memoization. So basically what this means is that as we go through in this one, like how we did this one, we're going to go through, but we're going to remember what each value or what each index, like what its value is. So just like the last one, we're going to start at NC6. We're going to write that over here. And then NC6 is going to go over to NC5. Probably the best way to do that, but it's fine. Okay, so NC5 is then going to go over to NC4, which is then going to go over to NC, the C's are actually C's, 3, which is then going to go over to NC 2, which is then going to go over to NC 1, which is going to go down to NC 0. So basically the same as last time. This is a C1 plus 0. It's going to equal 1. Now this would save it, however, it's already saved in there. So actually, no, it does save it in there just because they're all equal to infinity at the moment. As you can see here, I have it set to, and the light's kind of messing this up. I have it set to if r of n is less than or equal to n, return r of n. And then also r of n equals min v. So we're going to find that min v of 1. We're going to index that in r of 1. So that is now saved. Now we're going to go up here. So this is also going to be a C1. This is 1, so it's going to come up here. It's going to equal 2. 2 is also going to come to NC of 0. This is going to be a C2 plus 0 equals infinity. Then we are going to go and save. So this is going to pick out of here. This is a C1, by the way. It's going to be 2. We're going to come over here. We're going to see that. We're going to save it in here. So 2 is now 2. Now NC3 is going to come out. And it's going to go to NC1, which it's not even going to do anything with because we already know what NC1 is. It's 1. So this is going to be a C2 plus 1, which is going to equal infinity. Then it's going to come out to a NC0. It's going to be a C3 plus 0, which is going to equal 1. Between these three, it's going to pick the minimum value, which is, of course, going to be 1. And this is going to be a C1 plus 1, which is going to equal 2. So then we're going to save that value in here as of 1. And then we're going to come over here to NC4. This is where it's going to start being a lot more helpful. So NC4, handshake it a little bit, is going to go over and it's going to start going to NC2. We know what NC2 is, so we don't actually need to do anything with that. We know that this is a C2 plus 2, which is going to equal infinity. Then it's going to come over to a NC1. Once again, we know what that is, so it's going to be a C3 plus 1, which is going to equal 2. Then finally, it's going to come over to a NC0, which so C4 plus 0 equals 1. So C1 plus 1. We're going to say 4 as 1. Now we're going to come over here to NC5. I'm going to have to draw this out kind of far. It's going to come out to NC3. We already know what NC3 is. It is 1. So this is a C2 plus 1. But we know that equals infinity. Then we're going to come out to a NC2, missed a C there, which we already know what that is. That is 2, so this is going to be a C3 plus 2 equals 3. Then it's going to come out to a C, well, didn't let me write this first, but C4 plus, it's going to be plus 1, because it's going to be an NC1. Sure you know what that equals. It equals 1. Finally, it's going to come out. Oh, what's the finally it's going to come out. I'm just going to do this up here. NC0, which is going to become a C5 plus 0 equals infinity, because we don't have a 5-cent coin. So out of all these, you got 2, 3, infinity, or 2. So you're going to go with 2. So it's going to be C1 plus 2, which is going to equal 3. So then we're moving on here to NC6. I'm going to pause the video for a second. Okay, I shook out my hand and I'm back. So NC6 is going to go to NC6 is going to go to NC4, NC3, NC2, NC1, missing some C's there, and NC0. This is going to result in a C2 plus 1, which is going to equal infinity, a C3 plus 1, which is going to equal 2. We're using all this by all our log numbers. I did forget to log 5. 5 is 2. Then we have NC1, which we know is 1. This is a C4 plus, no, wait, this is a C5 plus 1, which is equals infinity. This is a C6 plus 0, which equals infinity. This finally is a C4 plus 2, which equals 3. So this is the one that's going to be selected. 2 is going to go up. I'm going to briefly go over the time complexity of this compared to the time complexity of the naive sort. This one is obviously much smaller. Naive sort has a time complexity of big O of 2 to the power of n, as you can see. For example, for n of 2, or if you're using num coin of 2, it's going to end up having 4 nodes. So basically 4 runs, and that is of course 2 to the power of 2. And then if you're doing 3, it's going to have 8 runs. As you can see here, 1, 2, 3, 4, 5, 6, 7, 8 right there. So that is the time complexity of this. So you got big O, 2 to the power of n. For this one, on the other hand, so for n of 6, you have a total of 1, 2, 3, 4, 5, 6 runs, For N of 5, or for NC5, you have 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. 7 runs. So this is 7 runs. This is going to be 6 runs. This will be 1, 2, 3, 4, 5 runs, and so on and so forth. So, long story short, this is 1 plus 2. So we're starting here. That's 1 run. This will be 2 runs, 3 runs, 4 runs, 5 runs, 6 runs, 7 runs. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus n plus 1, actually, in this case. But either way, that's going to come out to something along the lines of n plus 1 over 2, n times n plus 1 over 2, which is equivalent to n squared when we're talking about big O of n. So obviously the time complexity is much better on this one as compared to this one, which, makes sense. You're saving more information. It probably would take up more memory to do it this way, but I think those are pretty different time complexities, so I would say it's worth it.